number 18, it says two identical resistors are connected in parallel. So that means that I'm just going to start right here with the resistance of R connected in parallel. So that means you have two resistors, right, like this, connected in parallel. Does that make sense? All right. And what is their resistance? R and R. Then they are wired in series to a 40 ohms resistor. So now they are wired in to a 40 ohms resistor. So this is like R3 and this is 40 ohms. Okay? And this is like R1 and this is like R2.
But R1 and R2 are identical.
But they're identical, so they equal R. And the total resistance of this thing is what? 55. Okay? So we did it. You got to be careful. All right? So now let's do the math. So the first thing I got to, and we're asked to solve for R. Does that make sense? So first things first, we've got to set this up. So really the total, if we do the parallel first, so let's focus on this parallel. I'll do it in the same color so we don't get too confused. So the parallel is what we should probably do first, and we'll do it symbolically. So we're going to say 1 over RP is equal to 1 over R sub 1 plus 1 over R sub 2. Is that right?
Yeah.
But what do we know those values to be? They're identical, so they're both going to be R. But we'll just leave it like this for now, okay? Now, that's connected in a series. So my resistance of the series is equal to RP plus R3. Is that correct?
What is R?
RP is R1 and R2.
Yeah. So if you want to think about this, so it's a great question. I'll try to label it for you. This whole thing we could treat mathematically like a separate resistor. This is the resistance of the parallel circuit. So RP is the total resistance of the parallel circuit. You guys with me so far?
Yeah.
That's wired in series with this third thing here. So now what I need to do is I need to solve for RP. Well, algebraically, I just need to reciprocate that, but I need to remember that I have to have a common denominator. Right? And the common denominator is R sub 1 times R sub 2. So if I hit the top and bottom with the opposite factor, I end up with R sub 1 plus R sub 2 all over R1, R2.
Mr. Adams.
Yes.
If they're already identical, then why don't they have common
Well, I'm getting to that. Okay. We know that they're a common denominator, and that'll work out in the end. You're right. You're absolutely correct. But let's just go through the math and do it. The reason her question is, Mr. Adams, we know that this is R and we know this is R. Why don't we just leave it as R? And in this particular case, it would work. But what if they're not the same? You still need to know how to write this formula, right? Because this part is going to be the same every time. So Mr. Adams is writing out an extra step. It's not necessary for this particular problem. But remember, I'm trying to teach you how to set up for all the problems. Okay? Yeah, I know they're R's. I know they're a common denominator. Yes?
Would they be adding on the denominator too?
No, because what you end up with here is you end up with R2 over R1, R2, and then R1 over R2, R1. And so the numerators are added, right? But the denominator is the common denominator, okay? So now we need to reciprocate that, and when you reciprocate that, you get RP is equal to R1 times R2 all over R1 plus R2. Does that make sense? But now here's where it gets interesting. RP is really, what's R1? This is just R. What's this?
R.
R, and then this is R plus
R.
R. Does that make sense?
Yeah.
So RP is really R times R on the top, which is like R squared, all over what?
R.
2R. And so when you reduce that down, you get that the resistance of the parallel circuit is just going to be R over 2. Does that make sense? So now when we get down here, we did a lot of fancy work to just simplify it to R over 2. What's the resistance of resistor 3? 40 ohms. And what did we say the total was? 55. Oops. So we've got 55 ohms here is equal to R over 2 plus 40 ohms here. Does that look right to you guys? So now when I subtract 40 from both sides, I get 15 ohms equals R over 2, multiply both sides by 2, and I get 30 ohms is the value of R.
This was way easier than
Well, the other one was wrong. That's why this one's easier. All right, so just to kind of recap, because that was kind of a long problem. What we had is we had 2 resistors in parallel. That was labeled a resistance of R. And then it was connected in series to another resistor that was 40 ohms. But the total resistance of this thing was 55 ohms. Okay?